sell you a camera, you take your pictures, then they charge you for the development, and they keep the camera, and they make lots of profit, and you have to pay lots of money. So we went about reverse engineering this. They had a proprietary connector. That wasn't too hard to figure out. It was based just USB. All cameras have some sort of authentication. So they have a challenge response, and there's a secret algorithm, and you don't know it. And if you give the right response for the challenge, you're in. So here's the first model. The download command was disabled, but peek and poke, the low-level read-write commands, were not disabled. So what did we do? We reverse engineered the flash interface, and we read the whole flash byte by byte, undid the wear level algorithm, and then got a file system we could mount, and we got our pictures. So first vulnerability. Second one, you could write a location to memory location EE7, and that's the variable that tells whether it's locked or not. So you could just tell it it's already unlocked. So, or you could read EE1 to EE4, which is another memory location, and that tells you the correct response it's looking for. So just tell it those numbers back, and it'll be happy. And then on this first camera, the last thing we had was you could reverse engineer the whole challenge response algorithm. And if you just looked at the code in there, you could tell it was just a simple serial number multiplied by 4, converted to decimal. And so now that's actually in Gphoto. So if you've got one of these old cameras, it'll just Gphoto read it. Second generation camera, algorithm's no longer in firmware. It has 1024-bit security, sounds good. But you can ask for, there's a protocol, and you can ask for is the camera unlocked word. Normally that's 4 bytes, but if you say 2.5 megabytes, you get a megabyte of junk, and you get the most recent picture. So they weren't really expecting that. There were only also 6 to 8 challenge response pairs seen in the wild. So 1024 bits for that, but they only used a couple. So once one person figured out the correct response for the challenge, then they were all unlocked. So another one, they had a proprietary image compression format, which was really weird, and we never figured that out. But we figured out how to reflash the firmware and make it look like one of these other cameras that isn't locked. So that's another vulnerability. And then, let's see, and then the camcorder, the last model. It's basically the flip video camera, if anyone's seen that. This is the same thing, except the flip is pre-hacked. So now they've got unique keys on this. And they have this great algorithm in there that prevents buffer overflows with this formula here, which doesn't do anything. So it lets you get the challenge and the response back, and you can't get the byte past the response, but all you need is the response you're looking for. So someone messed up, should have been and 100. And then the last vulnerability, they left the algorithm on their FTP site, and we figured out that the challenge is actually just 40-bit RC2, and so we brute forced it, and took 21 PC days, which was actually a weekend because we had a whole bunch of computers going, and now forget about this line. So yeah, so we basically brute forced it, and then a bonus one. To generate their challenges, they used MS-RAND, which is from GW Basic, which is supposed to give you 16-bit numbers, random numbers, not 1024-bit random numbers. So actually, the security of that is more like 24 bits. So 1024 sounds good, but it's really more like 24. So that's it. 4 minutes, 13 seconds. That's my first. Then I get my second presentation. This one's more constructive. I Pong an asteroids watch, and unfortunately my luggage is on the way to the hostel, so it's, yeah, I've got the watch, but the batteries are dead, and if you see me tomorrow, I'll have it working, but until then there's this. So this is a project I made. My inspiration was this Pong clock, wall-sized clock. It's beautiful. I also like this, Dixie Tube watches. This one's the one that Steve Wozniak wears. It's got 2 digits. It's nice. I met the guy that made that. He kind of inspired me, but I wanted to do it my own way. So I got an OLED display, which just looks beautiful. And there's what the package looks like. And I did a prototype, hardware prototype to develop the software. So I've got just a big old computer board, some glue logic, and my OLED display that's the actual one that's going to go in the watch. And I use that to develop the gameplay. But I needed a better microprocessor. This is a fast talk, so I'll go quick. This one's smaller, lower power than the one that I had in my original one, and it's got an accurate clock, so that it actually keeps time because you want to watch to do that. And I used a better power supply. This one's super tiny. I could have used a lithium battery, like just non-rechargeable. That would have given me 8 days of life. But you'd have to change it every 8 days. So I use this 33-hour one, which is rechargeable. So you can just charge it every night, which I did not do. So the neat thing is about making a watch is that you get to design your own case. So it's just an inspiration. I like that square one. This one looked a little easier for me to make, kind of in shape. This one I love, but it's a little too complicated for me to make. I'm not quite good at machining, so I'm more software. So here's my first case. Just basic square and some cutouts in the back for the stuff and a little hole for the battery charger. I prototyped it, and here's me milling it out of wood. And there's the first wood prototype. It's not too wearable, but so I made a plastic one. And so here's a 0.5 millimeter pencil, and if you see over there, there's the smallest parts in the whole thing. So I had a microscope to solder it all up. It's the watch. It's going to be small. So there's the main circuit board for the first watch, and there's a dime, pretty small. There's the power supply, the processor, the crystal that keeps time, the connector that goes to the display, and then you can tell I laid the board out from left to right because I had some room on the right side when I was done to put my name in it, so I had to fill it. So here's the inside of that watch, and that's what it looks like with the battery on the right and the processor board on the left, and underneath it all is a display, which kind of drives the whole size of the thing. And there's a finished product for my Pong watch. It works just like the Pong clock. What I loved about the Pong clock is that every minute the right side makes a point, and every hour the left side makes a point. So if you look at the score, it's actually the time. So I stole that totally. I worked on a second version. This one has an accelerometer. And I'll show you the second version when it's done, but this is just a little side note. This is the world's smallest Pong game. It's, there's a penny, it's small coin. It's actually got a LCD display on there with it's liquid crystalline silicon, and the silicon has a Pong game built into it. So this whole thing is like a 1/4 inch. I'm not sure what that is in metric, but small, the whole display. And it plays Pong, and this was shipped in millions of cameras, and it was a secret. Don't tell anyone. It was like my company, some engineers, rogue engineers did that. So here's here's the final slide, the Asteroids watch. And then there's the original Pong watch and the Asteroids watch. So I don't have it charged right now. When I get my luggage, I'll have it tomorrow. So if you see me, I'll have a shiny red backpack to stop me, and I'll be wearing it, and you can see it. So that's it.
Okay, thanks, John. I think the videos were worth changing the laptops and to have some interruption. The next talk will be about an upcoming community meeting. Again, I give you the keywords. It's Whiteland, community, meeting, and game. And Whiteland is a real-time strategy game, so we will be hearing about this now.
Right, so yeah, it used to be like, oh, they've got this new nice phone and it has games, and do you have that game? And now it's all, I have this game thing, and you can also talk with it. I think the next step will be like, does your watch have that game? So that was quite nice. Let us